Hello everyone, this video is designed to help you translate an ER diagram or an entity relationship diagram into a series of tables in MySQL. We're looking here at a simple example with 4 entities: customer, order, item, and address. These 4 entities are connected through relationships: a one-to-one relationship, a one-to-many relationship, and a many-to-many relationship between order and item. We will now explore how to create each of these relationships in MySQL. Let's start by creating our tables. I will begin with the customer table. I'm going to create 3 columns in this table. They correspond to these 3 attributes in my ER diagram. The first of them is customer ID, and it's a primary key on this table. In order to set this as a primary key, I will need to define it as primary here on the right. I would also like to set this to auto increment, as indicated by this heading for AI, auto increment. What this does is it tells SQL to insert automatically a unique ID for each row in this table. Now let's add first name and last name fields. These can be varchar of a specific length. Now, here's an important piece. Don't forget to set the storage engine to InnoDB. The default may not be InnoDB on your setup. It's likely to be MyISAM. And you'll recall that we will need to use InnoDB as a storage engine in order to enable constraints. Okay, so my first table has been set up, customer table. I have a primary key and a couple of attributes here set as the first name and last name columns. I will now proceed to do the same for the order, item, and address tables. Let's look at the order table first. What's interesting about the order table, beyond the fact that it has the same structure as the customer table, is that it has a date field in addition. So make sure you set the data type in a way that corresponds to the field that you're creating. For this table, I will also again choose auto increment. You'll notice that when I set auto increment, it directly and automatically sets also a primary key at the same time. Don't forget the storage engine, InnoDB, and I should be good to go. Notice that it says order is a MySQL reserved keyword. It's not a problem, it's just warning us that, hey, we're using the word order in this column name. But order is also an actual special keyword in MySQL. If you were to do a query, an order by date, for example, you might use the word order as part of your SQL query. So this is just a warning to indicate, hey, maybe you don't want to use the word order as a column name. That's going to be kind of confusing. But it's not going to stop us. It's just giving us that little warning, and it'll proceed just fine. So maybe in future, keep in mind it's best practice not to use MySQL keywords when naming MySQL table columns. Here I will make the item table. It has an ID just like the other tables. It also has 2 text fields, name and description. For description, I might like to use a longer text field than varchar will allow. So let's use, for the description field, a different data type, text. The text data type allows us to store more information than varchar, which is limited to a certain length of values. You'll notice that if I leave one of these items blank, it'll just ignore it when I hit save. So even if you have only 3 fields, it's okay to have 4 of them. As long as you leave one of them blank, it should complete without any trouble. So finally, let's create the address table as well. Just fast forwarding ahead here, you can see that I filled all of these out. Once again, the storage engine I've marked as InnoDB. So here's my completed address table. Let's get an overview of the database by going to the top level here. And you'll see that I've actually forgotten to set one of them to InnoDB. So I need to go back in and fix that. When I go into this table, the item table, I'll go to the Operations tab. And there, I can actually adjust the storage engine from MySQL to InnoDB. This generates the SQL needed to make the shift. If I go back to structure now and to the overview, I can see that the type is consistent throughout. Let's now turn our attention to the relationships that are here in our diagram and how to create them as tables and columns in MySQL. Let's start with the customer places an order. This is an example of a very common type of relationship, a one-to-many relationship. One customer places many orders. So, for any given order among the many orders, there is only one possible customer. In order to link each order to one specific customer, we will need to reference a customer by their ID number. This customer ID needs to be referenced by each order. So in order to achieve this many-to-one relationship, the best way to go about it is to think about adding to the order table a foreign key that refers to the primary key on the customer table. By adding this foreign key to the order table, we'll be able to create this link and to set up a many-to-one relationship. Let's head back over to phpMyAdmin and set this up in the table structure. So, let's go to the order table and recognize that in the structure we need to add a customer ID. So, I will add one column to the order table at the end, and this is going to be customer ID, and it's going to refer to the order table. Rather, it's going to link the order table to the customer table. So what we'll see now, if we expand all of these columns for both order and for customer, the customer table has a customer ID column, and it's the primary key. But the order table now also has one with the same name. And so this field will link to this one. Now, we need to set up that constraint so that it works properly. In order to do that, let's go back to the order structure. And notice we have this relation view button here. When I go into relation view, I am enabled the options to set up a foreign key constraint. So, let's follow a naming convention here. If I start with the table name that I want to refer to, in this case, customer, and then the field of on that table that I want to refer to, customer ID, and then I put at the end FK for foreign key. This would be a great way to name it, the constraint, because it would be easy to find back, and it follows the kind of standard of the table name, the field name, and then FK for foreign key. Technically, you can name this whatever you like, but here is a good convention to follow. So in this case, the column that I'm referring to is customer ID, and I want to link it, this field, to the one in the customer table. So let's select the customer table, and we'll see that it automatically selected customer ID as the column. That's because customer ID is already the primary key in the customer table. I'm going to hit save now, and you'll see that it has created the SQL to add these constraints. Alter table, add constraint, foreign key, references customer ID. If I now go to the overview of the structure, you'll see that customer ID in the order table exists and has this index on it. The index is named here. It's the one that we created. And it's a foreign key that refers to the customer ID column in the customer table. So that's it. We've created our first many-to-one relationship between order and customer. Let's move on to the relationship between order and item. Now this is a many-to-many relationship. There are many orders that can be placed, and each order might contain many items. So in this case, the creation of that relationship is a little bit more complex. The best way to make this work is that we need to create a table to store the relationship between order and item. This new table will house the relationship between order and item and will contain an order ID and an item ID to reference both. Let's see what that would look like on the database side. To start, I will create a new table to house the many-to-many relationship, and I'll give the table a name so that it's easy to find back. In this case, the table will house a relationship between orders and items. So I'll call it order_item. This is a kind of naming convention that reminds us this is a relationship table between two other entities. I'll only need two columns here. The first one will refer to the order table, and the second will refer to the item table. Having created these columns, I'll now also need to set up the relationship and the constraints. However, as you can see, those options are currently not visible. And as you may have guessed, it's because I didn't set up this table as InnoDB. So I'll go back to operations and make sure that the storage engine is correct. By setting it to InnoDB, I will unlock the foreign key constraint options. Having done this, I can now go into Relation View and set up my many-to-many relationship. So, in this example, we will need two constraints. The first one will refer to the orders table, so I'll name the constraint order ID FK. The column in this relationship table that will refer to the order table is order ID, and the table in question is the order table. So this column and this column that I'm referring to here are respectively this column and this column in my hierarchical map. So let's save that, and we'll also add a constraint for the items. It has a name similar to the first constraint, following the same convention, but instead of referring to orders, it refers to items. When I choose the item table, it automatically selects the primary key that I've already created there. And that's it. I've set up a many-to-many relationship by adding these constraints to my relationship table. The final relationship that we want to set up is a one-to-one relationship. And this is a less common type of relationship. In fact, it would be more intuitive, perhaps, to model this as a one-to-many, so that any given customer might have multiple addresses. But for the sake of demonstration, let's assume that a customer would only live at one address. So we have a one-to-one relationship. How would we create this in MySQL? In this case, we have an address ID on the address table and a customer ID on the customer table. These are both primary keys, but we want them, in this case, with a one-to-one relationship, to be matched together. So where you have an address ID, it should lock only to one customer ID. In order to create this, what we need to do is go to Relation View and add a foreign key constraint on the address ID field so that it maps onto the customer table. This may not seem intuitive because the address ID refers to a specific address, not intuitively to a customer. But by making this constraint, we are locking them in such a way that they're synchronized, and that you'll only ever have one address referring to one customer. You'll notice that it didn't actually let us do this, because this constraint already exists. We already created a constraint with this exact name when we were working on the orders table. So what we'll have to do is to give it a slightly different name in order to continue. In this example, I'm referring to the customer via the address table. So if I give this prefix, I'm making my constraint name more specific. You can see, now that we've updated this name, it doesn't conflict with the existing constraint that we've added already from the orders table. For reference, here is that constraint which we created before on the orders table. It's not allowed to have the same name as another constraint elsewhere in the database, and so we've had to adjust the naming of this constraint so that it's unique. We've now finished setting up all the tables and relationships for this entity relationship diagram. In conclusion, I'd like to show you how you can export the database structure for submission with your assignment. One way, of course, would be to take screenshots of all of these different tables in order to demonstrate the structure that you've created. If you want to do that, that's fine. However, there is another way to go about this that will be more efficient. So, let's go to the top level of the database, where we can see all of the tables together. Now, looking at the database view, if I go to Operations, if I go to Export, I have the option to export all of the tables from my database in SQL format. So let's give that a try and see what we get. You'll notice that I have just downloaded an SQL file. I'm going to open this in a text editor. Here I'm looking at the SQL file that was generated by phpMyAdmin, and it shows us all of the SQL to create the table structure that we've just established. Here is the SQL that it generated for creating the address table. Notice it specifies the engine, and here for the customer table, similarly, the item table, the order table, and the order item table that we made to house the many-to-many relationship between orders and items. At the end, it also modifies each table to locate a primary key for each one, and it also adds the foreign key constraints that we created. So here's the constraint for address and customer. It references the customer ID. Here's the constraint for the customer ID on the orders table. here are the constraints on the order item table that specify our many-to-many relationship. So, by exporting your SQL structure, you can define all of the work that you've done for this project quickly and easily. And I will accept this probably in preference to a set of screenshots, although it's up to you which one you would prefer.